Section 5.4 is solving compound inequalities. Two inequalities such as x is greater than or equal to 3 and x is less than or equal to 7 form a compound inequality. A compound inequality containing the word and is only true if both inequalities are true. So it has to be true for both of them. The final graph is where the graphs of the two inequalities overlap. This is called the intersection of the two graphs. So let's look at x is greater than 3, greater than or equal to 3. Would we have an open or a closed circle at 3? Closed circle at 3, and it goes to the right. Now let's right below that, x is less than or equal to 7. It's going to be a closed circle, and it would go to the left. So if we combine these two with the word and, it has to be true for both. So if we grab this graph and we merge them together and they land on top of each other, where would the graphs overlap? From 3 to 7, right? So that's where they would overlap. Now, when we have two equations formed by the word and, we have to put in what is called a combined inequality, where we put x in the middle, less than signs on both sides, and in this case, because it's an equal sign, we'll put less than or equal sign. The smaller number on the left and the larger number on the right. And that kind of makes sense, because don't you read from left to right and it goes smaller to larger? So if we did that, which is smaller, 3 or 7? 3. So 3 goes on the left and 7 goes on the right. So that is how we would write a combined inequality. So if you ever have two equations formed by the word and, you have to solve each one and then you'll put it in this solution. Now let's graph it. The graph would be a closed circle at 3, closed circle at 7, and everything in between. If I asked you to read what this means or write a sentence, we would read this as x is between and including both 3 and 7. Now, it's very important that you have to say we're including 3 and 7. If it had just, there was no equal sign right here, we would just say x is between 3 and 7. If there was an equal sign here but not an equal sign here, we would have to say x is between 3 and 7 and including 3, which we'll do some more examples like that. Now sometimes it might be written, the problem might be written already in a combined inequality. Our goal is to get x in the middle and less than signs on both sides. If you can see this, here's a less than symbol and here's less than symbol, but we have more stuff. We just want x. Cover this up. What if we just had this? We just had this part. What would we do to get x by itself? Add 3. Well, we're going to do the same thing, but there's like two sides of the equal sign. We're going to add it to itself. We're going to add it on the right side, and we're going to add it on the left side. So we're combining, it's like two equations into one. What's negative 3 plus 3? 0 is less than or equal to 2x. So 3's go away, is less than 8. Now our goal is to get x by itself. Again, if we just had this, 2x is less than 8, what would we do? Divide by 2. So we treat it the same thing. So we're going to divide by 2. Now what is 0 divided by anything, class? 0. and 8 divided by 2 is 4. Now the sentence would be, so when you read it, x is between 0 and 4 and includes 0. Something to that nature that you have to include 0. We are going to have a closed circle at 0, open circle at 4, and everything in between. Okay, example 1b. We're going to solve in graph. All right, we have two separate equations formed by the word and. So we're going to add 3. Y is greater than or equal to negative 8. The second equation, we're going to add 3 and get y. Oh, make sure you bring down the word and. Don't forget to copy down that and. Is less than or equal to negative 5. Now, when we have two equations formed by the word and, we have to go one step further and put it in a combined inequality, where we put y in the middle. What signs are we going to put on both sides of y? Less than signs. And in this case, it'll be less than and equal to. Less than or equal to signs. Smaller number on the left. Which is smaller, negative 8 or negative 5? Now notice, y is between and including both negative 8 and negative 5. Something to that nature, that you have to include both. We're including both of them because both of them have the equal sign. Now let's graph it. Okay, so there's the graph. Y'all try to do this one by yourself. So to graph it would be closed circle at negative 4, open circle at 1, and everything in between. Example 3, when we have the word or means the union, and is the intersection. Or it only has to be true for one when it's or. It's either one or the other. And it has to be true for both. So if we have two equations formed by the word or, we're going to solve each one separately. So we're going to subtract 7 on both sides. So that's negative 2m is greater than or equal to 13 minus 7 is 6. Divide by negative 2. Now remember, guys, what happens when we divide by a negative number? We flip the symbol, so it's a less than or equal to. 6 divided by negative 2 is a negative 3. Okay, let's solve the other equation. We're going to subtract 12 on both sides. So that's 5m is greater than 25. Divide by 5. So m is greater than 5. And make sure you bring down the or. Now, when we have an or, we do not put it in a combined inequality like we did with the and. Okay, we cannot do that. This is the answer. Okay? Do not try to put it in a combined inequality where we put the variable in the middle and less than signs on both sides. It will not work. Let's graph it before we write the sentence. It's a closed circle at negative 3, and m is less than or equal to negative 3, so that's to the left. And m is greater than 5, open circle at 5, and it goes to the right. So when we have an or, usually they're going to go in opposite directions. Just strictly, m is less than or equal to negative 3, or m is greater than 5. No special sentence for that. We only have a special sentence when we have an and, where we have a combined inequality. We're going to subtract 1 on both sides. we have two separate equations. So that's A is less than 3. Bring down the word or. A is greater than or equal to 4. So let's graph this first. Open circle at 3, and everything to the left that's less than 3 is to the left. Or A is greater than or equal to 4, close circle, and it's to the right. Okay, so, oh, yes, I'm sorry. Thank you. A is greater than or equal to 4. Okay, example 3C. The very first equation, x is less than or equal to 9, it's already solved, so there's nothing to do there. We only have to solve the second equation. So we're going to subtract 2 on both sides. 4x is less than 8, then divide by 4. So x is less than 2. So I'm going to bring down the x is less than or equal to 9, or x is less than 2. So there's the answer there. Now, let's graph these two. So x is less than or equal to 9, or x is less than 2. Now, the other two graphs we had, or they went in opposite directions. And usually they do, but every once in a while they go in the same direction. And remember, for or, it only has to be true for one. So where does the graph start? Where does it start being true for just one? At 9. And everything to the left. So let's pick like 5. Is 5 less than or equal to 9? Yes. Is 5 less than 2? No. But it only has to be true for one. Now, what if it had the word and? What if it said and? What if it said x is less than or equal to 9 and x is less than 2? And means where the graph overlaps. So where does it start overlapping? At 2. Okay, so what would the answer be for that one if it said and? X is less than 2. But if it's an or, the answer, so it really wouldn't be both of these, it would just be this one. The human ear can only detect sounds between the frequencies 20 hertz and 20,000 hertz. Write and graph a compound inequality that describes the frequency of sounds humans can hear. Okay, let's see. Think about this for just a minute. He can detect between. What word went with between? The and. Where we put it in a combined inequality, where we put the variable in the middle, and what went on each side? Less than or equal to, and in this case, less than or equal to. Smaller number on the left, which is smaller, 20, and larger number on the right, which is 20,000. So that means you can hear anything between 20 and 20,000, and including 20 and 20,000. Okay, so how are we going to graph? So will we have an open or a closed circle at 20? Closed. And an open or closed circle at 20,000? Closed. And everything in between. Now look at the second part. It says, write and graph a compound inequality that describes the frequency of sounds humans cannot hear. X is less than 20, or X is greater than 20,000. So the graph, I'm going to count by 5,000s again. A company is manufacturing an action figure that must be at least 11.2 centimeters and at most 11.4 centimeters tall. Write and graph a compound inequality that describes how tall the action figure can be. Okay, first, let's look at this. It must be at least 11.2 centimeters. What is at least? What inequality stands for at least? Less than or greater than?
No, greater than or equal to.
Greater than or equal to. So x is greater than or equal to 11.2. And, so we're going to use and, at most. That means the highest it can be, so can it be less than that? Yes, so x is less than or equal to 11.4. Now, do we leave it like this? No, because when we have an and, we must rewrite it, putting x in the middle, less than signs on both sides, in this case, less than or equal to, smaller number on the left, which is smaller, 11.2, and 11.4 is on the right. Now, when we go to do our number line, we've got decimals. So we've got 0.1, 0.2, 0.3. So we're going to just focus on between 11 and 12. Here's 11, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.10, and then 12. So 11.2 is right here. Closed circle, and 11.4 is right here, and everything in between. So it doesn't give you much leeway for the action figure, the height for the action figure. Together. So skip over to number 13, please. We are going to solve for x. So we are going to add 13 to both sides, on the far right and on the far left. Negative 4 plus 13 is 9, is less than or equal to negative 3x is less than or equal to 13. Hello, I need to add 39. Okay, now I'm going to divide by a negative 3. Now think back. What happens when you divide by a negative number? We flip the symbol. So 9 divided by negative 3 is a negative 3. We flip it to a greater than or equal to x. Flip that to greater than or equal to negative 13. Now this is backwards. Remember, when you have a combined inequality, what has to be on each side? Less than symbols. And the smaller number on the left, larger number on the right. Is the smaller number on the left? No. So basically what we do is we pick up this whole thing and flip it around. Okay? So we have to do that. Put less than signs on both sides. Smaller number, which is smaller. Negative 13. See, look right here. It's pointing to negative 13. When I flip it, it's still pointing to negative 13. It's open to negative 3. I'm going to put a negative 3 right there. It's still open to negative 3. So I picked it up and moved the whole thing.
So the signs change again?
The symbol's changing. When I go to flip it around, yes. And then to graph it, oh, I don't have to graph this problem. And that is it.